All right, today we're going to look at some slope-intercept form lines and review a little bit of what we did today. Today's class, we were asked to graph a line in slope-intercept form. So when we do that, we have to identify the slope, and in this case, the slope is 3, and we're going to write that fraction as 3 over 1. And we're also going to write it as a fraction that's equal to that, which would be a double negative as negative 3 over negative 1. And to do that, it changes our direction. The second thing we're going to do is we're going to identify the b. The b is the y-intercept, so where it crosses the y-axis. B is going to always have a 0x coordinate, and it's going to be, and it's going to be the point that is existing when you have the constant after the x. So in this case, it's going to be negative 1. We're going to plot that point as negative 1. And then we're going to use the slope, the rise and the run. So we're going to go up 3 and right 1. But we could also use the second slope here and go down 3 and left 1. And in doing so, it creates, as you can see, this nice friendly line, which looks like this. Now, we've identified the slope and we've identified the y-intercept. Now we're going to do the reverse. So this time I'm going to give you the graph and we're going to identify the parts that we need. The first thing we're going to do is we're going to identify some key points along the graph. So in this case, I can see the y-intercept is that point right there. Let's make it more friendly. Is that point there. And then I'm going to find another point that crosses along the grid line. So if I kind of go up and follow this line, I see there's a point there, there's a point there, there's even a point there. My next goal, if I'm looking at this, is to try to find the slope. So I'm going to find and count from one point to another. In this case, I go positive 1 up and positive 1 right. So my slope is 1 over 1. That slope is going to go directly in to where my equation would say m, and in this case, it's going to say 1. Y equals 1x. Y equals 1x plus something. So what is that something? That something is my y-intercept. B equals 0, comma, and now I have to find where does it cross my y-axis. In this case, it crosses the axis at 2. So y-intercept equals 0, comma 2. And then I'm going to take that number and I'm going to plug it right in to there. So y equals 1x plus 2. That's my equation. Let's take a look at another one. Here we have a slope that appears to be negative, and we're going to try to find some grid lines that it falls on. So we have, it looks like this point here, it looks like this point here, and maybe even that one there. So let's find out. First of all, it looks like it crosses the y-axis at 0, 1. So we're going to put that 1 down on my B. 1 is my B, and it follows its way down. Next, my slope. So how do I go from one way to the next? This time it goes down 1, but it goes down 2 and right 1. So my negative rise is going to be negative 2, and my positive run is going to be a positive. I could also write this as positive 2 if I decided to go from this point up, but then I would have to go left. And that left creates my denominator of negative 1. Either way, if I took a calculator and divided these, I would find that my slope is negative 2. So the equation that I have to write for y equals mx plus b, I need to substitute two numbers. I need to substitute m for slope and b for the y-intercept. I counted my slope as negative 2. I can also check to see that that's a negative line by following its direction. And my y-intercept is where it crosses the y-axis at positive 1. In the next example, you're going to have a worksheet that is this number 1. And we're going to do this together. So in this example, it looks like my ordered pair for my m, it crosses the y-axis at 0. So I'm not going to have a y-intercept that's on the line. My y-intercept is going to say y equals, but then my b is just 0, 0. My b is simply where it crosses the origin, and I don't need to write that number. But just for now, I'm going to write plus 0. Now I need to count the slope. So the slope of the line is where I find another coordinate that it crosses on a grid line. So you can see here it doesn't cross, here's not on a grid line, but there looks like it crosses a grid line. So that's my next point. Now I can also go down and I can go, oh, it looks like it goes right there. So those 2 points give me that direction. And now I'm going to count. So from either point, it doesn't matter. I'm going to go up 1, 2, 3, and right 1. Up and right. Up and right are 2 positive numbers. So my slope is a positive 3 over 1. And then I just rewrite my x. And my slope-intercept form is y equals 3x plus 0, or just y equals 3x. Finally, in my last example, again, this is on your worksheet. Let's see if you can do this one. My slope is definitely going to be negative just because of the way that the line is drawn. So I'm going to write this already as y equals negative something x, and it's above. So there's my y-intercept right there. My y-intercept, it looks like, again, is at positive 1. And now I'm going to see if I can count some grid lines here. So nowhere along this line does it seem to go until it gets all the way out to there. And then if I follow this down, it doesn't seem to get on a perfect grid line until it gets to there. So we have those 2 points that we're going to now count. In this case, we can go from here. We're going to go down 3. So that's my negative number. And then right 5. So that's my positive number. So negative 3 and positive 5 give me a negative slope of negative 3/5. And then from there, I'm going to look at my y-intercept and find that it's a positive 1. And there's my intercept and my slope. So I wrote the equation in y equals mx plus b form. And you now have a few examples that you can go off of as you move forward.